Hi everyone, welcome to this chapter, Network Layer Summary. What did I learn in this module? Network Layer Characteristics. The network layer or OSI layer tree provides service to allow end devices to exchange data across network. IPv4 and IPv6 are the principal network layer communication protocols. Other network layer protocols include routing protocols such as OSPF and messaging protocols such as ICMP. Network layer protocols perform four operations: addressing end devices, encapsulation, routing, and de-encapsulation. IPv4 and IPv6 specify the packet structure and processing used to carry the data from one host to another host. Operating without regard to the data carried in each packet allows the network layer to carry packets for multiple types of communication between multiple hosts. IP encapsulates the transport layer segment or other data by adding an IP header. The IP header is used to deliver the packet to the destination host. The IP header is examined by routers and layer 3 switches as it travels across a network to its destination. IP addressing information remains the same from the time the packet leaves the source host until it arrives at the destination host, except when translated by the device performing NAT network address translation for IPv4. The basic characteristics of IP are that it's connectionless, best effort, and media independent. IP is connectionless, meaning that no dedicated end-to-end connection is created by IPv4 data is sent. IP does not require additional fields in the header to maintain an established connection. This reduces the overhead of IP. Senders are unaware whether destination devices are present and functional when sending packets, nor, nor are they aware if the destination received the packet or if the destination device is able to access and read the packet. IP operates independently of the media that carry the data at lower layers of the protocol stack. IP packet can be communicated as electronic signals over copper cable, as optic signal over fiber, or wirelessly as radio signals. One characteristic of the medium that the network layer considers is the maximum size of the PDU protocol data unit that each medium can transport, or the MTU. The next point important is IPv4 packet. The IPv4 packet header is used to ensure that a packet is delivered to its next stop on the way to its destination and device. An IPv4 packet header consists of fields containing binary numbers which are examined by the layer 3 process. Significant fields in the IPv4 header include version, DS, TTL, time to live, protocol header, checksum, source IPv4 address, and destination IPv4 address. The IHL, total length, and header ketchum fields are used to identify and validate the packet. The IPv4 packet uses identification, flags, and fragment offset fields to keep track of the fragments. A router may have to fragment an IPv4 packet when forwarding it from one medium to another with a smaller MTU. And finish with IPv4 packet. IPv4 has limitations, including IPv4 address depletion, lack of end-to-end connectivity, and increased network complexity. IPv6 overcomes the limitation of IPv4. Improvements that IPv6 provide include the following: increased addressing space, improved packet handling, and eliminates the need for NAT network address translation. The 32 bits IPv4 address space provide approximately this amount of unique addresses. IPv6 address space provide this amount or 340 undecillions addresses. This is roughly equivalent to very grain of sand on Earth. The IPv6 simplified header fields include version, traffic class, flow label, payload, length, next header, hop limit, source IP address, and destination IP address. An IPv6 packet may also contain AH, which provide optional network layer information. Extension headers are optional and are placed between the IPv6 header and the payload. AH are used to fragmentation, security, to support mobility, and more. Unlike IPv4, routers do not fragment routers' IPv6 packet. And Webster reflection question. More protocols. I'm beginning to understand that there was a great deal of work done to create these protocols. At the network layer, protocols handle addressing, encapsulating the data, routing the packets, and de-encapsulating the packets so they can be read. Mercy and Vincent are not IT professionals, so our working networks can seem a bit mysterious to them, but it does help to know about what happened at the network layer of the OSI model. How can this knowledge help you to troubleshoot your own network? And network layer quiz, which value that is contained in IPv4 header field is decremented by each router that receive a packet. This is time to life. Which statement accurately describe a characteristic of IPv4? IPv4 has 32 bits address space. Question 3. Which technology provides a solution to IPv4 address depletion by allowing multiple devices to share one public IP addresses? This is not network address translation. Why is IPv6 designed to replace IPv4? Because the IPv4 address space will soon deplete. Which characteristic of the network layer in the OSI model allow carrying packets for multiple types of communication among many hosts? This is, I don't know, the ability to operate without regard to the data that is carried in each packet. This is the answer correct. And which statement describes a characteristic of the network layer in the OSI model? Each protocol specifies the packet structure and processing used to carry the data from one host to another. Which layer of the OSI model is responsible for the logical addressing of packets? This is the network layer. And what is the order of encapsulation for the protocol data units PDU pacing from the user application down the stack? Data, segment, packet, frames, and bits. What process involves placing one PDU protocol data unit inside of another PDU? This is encapsulation. And what information is added during encapsulation at OSI layer 3? Source and destination IP address. How does the network layer use the MTU value? I don't know. I don't know what is this. But in my example, I achieved 82%. You have scored 82%. Congratulations, you have passed the test. This is all for this. See you in the next one. Bye.